Hi, good afternoon. My name is Warner Alexis. Today I'm gonna go to project with you guys. So for this project, I use NLTK Name Corpus, which contain around 7,900 English first name collected from public source. So each record name and its corresponding gender label. So either male or female. So this dataset is commonly used in NLP because of name often contain recognized pattern. So briefly, we outline what we're going to do in this project. So for data preparation, so what we have done, we randomly shuffle and split the data set into 500 name for testing and 5 for depth testing and also 6,900 for training. So we're only gonna choose one model. So our baseline model, which did really good, which is the naive Bayes classifier, using the last letter of each name as a feature. So for feature improvement, we add more features such as first and last letter, 2, 3 letter suffix, name length, value, and consonant count to improve accuracy. So for model tuning, we use the depth test to compare the feature combination and tune the model for better performance. So our final evaluation, we test the model on the test set and evaluate its accuracy, its precision, we call an F1 score, and also the create a work curve flat to see how well our model done. So so far for the data split. So I start by using the NLTK name corpus, like we said. So I divide the data set into 3 parts. So we talk about the 6,900 name for the training and 500 for development testing and also another 500 for final testing. So once the data was split, I create a function called gender feature, which extract patterns from each name, like first, last letter, and also the last few letter ending with the name and the number of vowel. So these features are important because they often reveal gender-related trend in name. For example, female name often end with a or E, while male name might end with consonant like N and R. So in this part of the project, I focus on transforming the raw data into a format that will easily use to model and then to learn from. So remember that we talk about the gender feature that we create to extract different patterns from each names. So these processes easily turn into simple text data into structure information, allow the classifier to recognize meaningful pattern that can actually predict whether a name is a male or a female. So, so after creating the the model, so we actually evaluate how well the naive Bayes classifier performed by using a confusion matrix and then several possibility-based metrics. So the confusion matrix allow me to compare the model's prediction with the actual gender labor test set. So for the result, so we correctly, so this is the confusion matrix. So for the result, we correctly identify 263 female name and 150 male name with the same misclassification. 51 female were predicted as a male and 36 name were predicted as a female. So this indicate that the model was slightly better at recognized female name, but still maintaining a strong overall balance. So then I use the model predicted probability to calculate more detailed evaluations such as precision, we call F1 score and AUC work. So what I've done is that these measures provide a more complete picture of the model performance, showing not only how accurate it was, but also how confidently and consistently it differentiated between male and a female. So, so the work curve give us a clear visual of how well. So when we look at the work curve, so this is where I calculate the precision. So this is the work curve. So the work curve gives us a clear visual of how well the model can tell a male from a female. So what we learned so far to different data science classes is that if work AUC is closer to one, that's mean the model perform very strongly in distinguishing between the two classes. So for a perfect model, we have an AUC of 1. So while random model will follow the diagonal dash line in the middle, because these curves stay well above the line, it's confirmed that the naive Bayes classifier is highly effective at predicting gender from name pattern and make consistent and confident prediction across various probability thresholds. So, so for me to test the model, what I've done, I actually create a small list of random word. Also put my name on it. So at this stage of this project, so what I trained the bias classifier to make this prediction of the name that I created. So what I've seen is that it correctly predicted my name as male, also Michael Taylor, and also Taylor has a male, and Ima and Sophia has female. Interestingly, the model predict Alexia as male, even though the name can be done to either gender. I don't know if it's because I'm Alexis. I usually put Alexis on everything I've done. So this result highlight how the model base is decision purely on letter pattern rather than cultural or contextual usage. So for example, name ending with consonant like R and S are often labeled as male in the training data, while name ending with vowel like A and E are commonly associated with female label. So overall, this model demonstrates its ability to generalize from learned character and pattern to new and unseen name to it might occasionally misclassify gender neutral, culturally ambiguous name. And thank you.